Happy Wednesday, kiddos. Today we're going to find the lengths of segments of tangents and secants. So first of all, let's remember what a secant is. And if you take a look at this picture right here, this is an external secant. So it goes through the circle in this fashion. And then this is a tangent to the circle because it only touches it once right there. Notice the secant crosses through the circle, touches it two places here. Okay, so then we're going to have these two theorems to talk about today. And the first one has to do with secant segments. So it's just saying that EA, so this part right here, times this whole thing is equal to EC times this whole thing right here. So we're going to use this theorem to do this example for this first part, and I want you to cross this out. So we're just going to fill in the blank. We have 12 times something is equal to 15 times something. Okay, so right here we need to know what the length of this whole secant is right here. And so 15 plus 25, that whole length is going to be 40. So then we're going to have 12. So 12 times this whole thing. Well, it's 12 plus x. So that's what's going to go right here, because that's the length of the whole secant right here. Equals 15. So this little part right here times this whole length. And we just said that 15 plus 25 is 40. And we're just filling in the blanks. We're just setting up the equation using the first theorem of today. The second theorem says that if you have a tangent, this is your tangent, and you square it. So you square the tangent, that's going to equal to this part times this whole part over here, which is ED. Okay, so that would be ED right there. So let's fill in the blank. So it's saying that x squared, we'll just call this x, so that's going to be x squared times 4. And then we have to have the whole length right here, which is 4 plus 5, which is 9. That whole length is 9. So that means you're going to have a 9 right here. So then that's how you would fill in and make an equation. Once you know how to make the equation using these two theorems, you can solve for it and solve for x. So this one's going to use the first theorem because these kind of look the same. So it is saying that if I multiply 9 times this whole distance, which is 9 plus 11, that's going to be 20, equals 10, which is that little part right here, times this whole distance, which is 10 plus x. So we have created this equation. We're going to multiply 9 times 20, that's 180. We're going to distribute the 10, so that's 100, plus 10x. Subtract the 100, because I'm trying to solve for x. And so I'm going to have 180 minus 100, that's going to be 80, equals 10x. And then divide both sides by 10. And so x is equal to 8. So that's my answer for this second example. Now what if you are standing on point C about 8 feet from a circular aquarium tank. So you're right here. That's you. And the distance from you to a point of tangency on the tank is about 20 feet. So this is 20 feet. And then we want to estimate the radius of this big tank. Okay, so first of all, we got to create the equation. So it's using the second theorem for today, where this one right here, we're going to use that. So we're going to use, that's your tangent line, so that's going to be 20 squared is equal to, and then it's this little part 8 times this whole distance right here, which is r plus 8. So now 20 squared is 400. And then I'm just going to combine the two r's to make a 2r plus 8. And then we're going to distribute. So that's going to be 400 is equal to 16r plus 64. We're going to subtract the 64. And so 400 minus 64 is 336 equals 16r. And then we divide by 16 on both sides. So then r is going to be equal to 21. And it's 21 feet. So the radius of this tank is 21 feet. So I hope you enjoyed today's lesson. Have a good day.